Okay, hi, BC Part 1. We left off in the last screencast talking about the mean value theorem, which states, as we know, that if a function is continuous and differentiable over an interval of x, there must be at least one point c, or x, between 3 and 7, such that the slope of the secant line equals the slope of the tangent line, which is right here. I left off by telling you that what we're going to talk about today in this context is the fact that these two slopes here actually describe rates of change. In particular, the slope of a secant line describes the average rate of change, and the slope of the tangent line, as you know, describes an instantaneous rate of change. We're probably most comfortable with the fact that instantaneous rate of change is the rate of change of some function at that moment, that particular specific moment. What I want to talk about a bit more in this screencast is this notion of average rate of change. When we talk about average rate of change, it's not enough just to stop and write average rate of change. An average rate of change is an average rate of change over a particular interval, okay? And the interval is whatever that interval is. Here, the interval is from x equals 3 to x equals 7. So the average rate of change over an interval of x from 3 to 7. I also like to even add one other piece. It's the average rate of change of what? Of f of x. Okay? Average rate of change of f of x over an interval of x from 3 to 7. I know I did this with you with instantaneous rate of change, but this means, I want to flesh this out even more, I want to add in the important details. It's the instantaneous rate of change of f of x, okay, not over an interval, because we're talking about at an instant, so the use of the word at some value of x equal to c, right? Because in this picture we don't know exactly what c is. It's just an example. Now, what this means, like these details here about average rate of change and instantaneous rate of change become particularly important when you look at something in context. So what I have done here is I have made up some fictitious data, and let's say this is like game 1 of a season, game 2 a season, game 3. Let's say these are lacrosse games, and the person here playing lacrosse is either going to be Thomas or Paige, since they are our two lacrosse rock stars, okay? On game 1, Thomas or Paige scored 1 goal. On game 2, Thomas scored 4 goals. On game 3, 3 goals. Game 4, 4. Game 5, okay, so on and so forth. And then I know that the goal function, right? So if you can see, the y-axis here is number of goals. The x-axis here is the game number. And so this is kind of like the goal function, right? What I did was I took these discontinuous points and I generated some function. Okay, I don't know what that function is. It's probably some, I know there probably is some function here, right? This is some function that, some goal function. And it's unfortunate that goals and game have the same letter, so let's just call this, goals, and I don't know, let's just call this, no, I don't want to do that. Let's call this number of scores, okay? Let's just change the word goals, number of scores. That way I can say this, okay? It's some score function where s is a function of the game number. That's important, all right? And then what I want to do is I want to do this. I want to find the slope of this secant line right here from 1, 1 to 6, 5, okay? The slope of that secant line. And the slope of that secant line, m sub sec, right, is equal to 5 minus 1, y1 minus y2, over 6 minus 1. This equals 4/5, okay? Now, the slope of that secant line is 4/5, but what I want you to do is tell me what this represents in the context of this situation, okay? 4/5 is the average rate of change in number of scores over the period of time, because here the period from game 1 to game 6. Okay? This is the average rate of change in number of scores over the period from game 1 to game 6. Okay? That's the average rate of change. Now, let's talk about what this means even more. This here, this number 4/5, 4/5, what are the units of this number? What are the units? I want to ask you this. Let's see. y1 minus y2, y is number of scores, right? So the unit of the numerator is scores, number of scores. The unit of the denominator is game. Okay? So this 4/5, if the units of this are scores per game. Okay? Or goals per game. I just didn't use goals because of the G. And what this means, I want to make this, like this is a little bit clumsy rolling off the tongue, but 4/5 scores per game, or to make this even more friendly, like 0.80, okay, goals per game. Okay? What this number means, to write the sentence out in a way that's a little bit less clumsy than this, is to write this. Okay? On average, between game 1 and game 6, Thomas scored an average of 0.80 scores per game. Okay, so very important. This, I think, makes more sense than this. Just whenever you're in context, there's always a nicer way to say that. So this is saying that if you look at the period of time between game 1 and game 6, on average, right? On average, Thomas scored an average of 0.8 goals per game, or scores per game. Okay? Units here are ever so important. You knowing what those units mean is so, so important. All right, very good. Now, let's talk about this. We want to know what the single most common mistake I see people making is. Look what we did here. To find the slope of the secant line, we found the slope of the line connecting those 2 points. People mistake this slope, which is the average rate of change of the function f over the interval of time from, x1 to x2, they mistake this for this. Look what they do. They say f of 6 plus f of 1 divided by 2, right? They say y value of 5 plus y value of 1 divided by 2, and they say this is the average rate of change of number of goals scored per game. That is not what this is. This is just saying, take a look at the number of goals that Thomas scored on game 1, and take a look at the number of goals that Thomas scored in game 6, and just average them. Add them together and divide by 2, right? That's what you do when you have 2 tests and you want to average them, right? You take the number of tests, 2 tests, you add the test scores, divide by 2. The units here would just be number of goals. He's just averaging the number of goals. This, when we do f of 6 minus f of 1 over 6 minus 1, this is the slope of the secant line connecting those 2 points, which is an average rate of change. Okay? All right. Now, I don't have a function for this because I just made up this problem, but let's say that I know this is the case. I'm going to go back to this drawing and say, let's say that I know that here there's a slope of a tangent line. Okay? And in this case, I think you can see that there'd be actually 3 places, right, where the tangent line would have a slope that's parallel to the secant line. And let's just focus on this one here. And I'm going to say, because I don't know what the function is, I just made this up. Let's say that this value here is 1.42. Okay? And I'm going to say, show or give an explanation about what's going on with Thomas in terms of his lacrosse game in the context of the mean value theorem. Well, this would say that at precisely the 1.4 at the 1.4 at precisely game number 1.42, comma, Thomas's instantaneous scoring rate in that moment is, what was the slope again? 0.80 scores per game. So there is, and again, this unit and this unit, they're the same unit. It's goals per game. But here we're talking about an instantaneous rate of change, like at that particular moment when time equals 1.42, or when the game number equals 1.42, okay? And that is it. And I know that this example is a little bit nonsensical because obviously we don't have game number 1.42, but I was just using this example to underscore the importance of units for average rates of change, units for instantaneous rates of change in the context of the mean value theorem. Okay, thanks so much, and now you are well poised to work on the problem set that includes a little bit of everything, which is why I named the problem set a little bit of everything. And with that, I bid you all good night.